In this video, I'm going to discuss some more problems on Lagrange's interpolation formula. So let us move to the problem. Find the interpolating polynomial f of x and then find f of 3 for the given data. So the given data are x equal to 0, x is equal to 1, x is 2 and x is 5. The corresponding value of y is equal to f of x 2, 3, 12 and 147. Here let us take x naught is equal to 0, x1 is equal to 1, x2 is equal to 2 and x3 is equal to 5. Corresponding y, that y naught is equal to 2, y1 is equal to 3, y2 is equal to 12 and y3 is equal to 147. Here we can observe that the points of x are not equally spaced because difference of any two consecutive values is not same. You can observe that 1 minus 0 is 1, so 2 minus 1 is 1, but 5 minus 2 is 3, so difference is not same, so they are not equally spaced values. So therefore we cannot apply the Newton's forward interpolation formula or Newton's backward interpolation formula. Therefore we can apply the Lagrange's interpolation formula to find the value of f of 3. So let us find out interpolating polynomial, then you can evaluate the value of f of 3. We have Lagrange's interpolation formula for given points, that is y of x is equal to x minus x1 into x minus x2 into x minus x3 divided by, we have to subtract from the x naught minus x1, x naught minus x2, x naught minus x3 into y naught plus x minus x naught, x minus x2 here, x minus x3 divided by, but subtract from x1 minus x naught, x1 minus x2, x1 minus x3 into y1 plus x minus x naught, x minus x1, x minus x3 should write here divided by, to subtract from x2 minus x naught, x2 minus x1, x2 minus x3 into y2 plus x minus x naught, x minus x1, x minus x2 divided by, I have to subtract from x3 minus x naught, x3 minus x1, x3 minus x2 into y3. So for the given data, I have written the interpolation formula. Let us substitute the values of x and y in the given interpolation formula. So that is y of x is equal to, where x keep it as it is, x minus 1, where x1 is 1, x minus 2, x minus 5 divided by, I have to subtract from the 0 in the denominator, so that is 0 minus 1, 0 minus 2 into 0 minus 5 into 2, that is y naught. So now let us take second term, x minus 0 into x minus 2 into x minus 5 divided by, I have to subtract from the x1 value. X1 is here 1, that is 1 minus 0 into 1 minus 2 into 1 minus 5 into y1 is 3 plus x minus 0 into x minus 1 into x minus 5 divided by, you have to subtract from x2. X2 is 2 here, 2 minus 0 into 2 minus 1 into 2 minus 5 into y2 is 12 plus x minus 0 into x minus 1 into x minus 2 divided by, let us subtract from the x3 value. X3 is 5 here, 5 minus 0 into 5 minus 1 into 5 minus 2 into y3 is 147. After simplification, we have y of x is equal to minus 1 by 5 into x minus 1 into x minus 2 into x minus 5, the first term, plus 3 by 4 into x into x minus 2 into x minus 5, that is second term. So minus 2 times of x into x minus 1 into x minus 5. So last term is so 1 by 60 into x minus 1 into x minus 2. So this implies y of x is equal to, that is x cube plus x square minus x plus 2. So this is the interpolating polynomial by using Lagrange's interpolation formula. To find f of 3, take x equal to 3 in the y of x. Therefore y of 3 or nothing but f of 3, so that is 3 cube plus 3 square minus 3 plus 2. This implies, so that is 35. So therefore y is equal to 35 at x is equal to 3. Now we'll move to the second problem. A curve passes through the points 0, 18, 1, 10, 3, minus 18 and 6, 90. Here you have to find the slope of the curve at x equal to 2. So by using the interpolation formula, you can evaluate the polynomial. So once if you find the polynomial, you can find out the derivative of the polynomial. So for that you can find the slope of the curve as the polynomial at x equal to 2. So by differentiating the polynomial function. Now let us move to the solution. So let us take the x and y in the table. When x is 0, corresponding y is 18. When x is 1, y is 10. When x is 3, y is minus 18. When x is 6, y is 90. So by using these data points, how to find the interpolating polynomial by using the Lagrange's interpolation formula, because you cannot apply the Newton's forward interpolation formula or backward formula because the values of x are not equally spaced. So therefore you have to apply the Lagrange's interpolation formula. Let x0 is equal to 0, x1 is equal to 1, x2 is equal to 3 and x3 is equal to 6. The corresponding value of y are y0 is equal to 18, y1 is equal to 10, y2 is equal to minus 18, y3 is equal to 90. So now we have Lagrange's interpolation formula. We have Lagrange's interpolation formula. So y of x is equal to x minus x naught into x minus x1 here, x1 into x minus x2 into x minus x3 divided by to subtract from the x naught, that is x naught minus x1 into x naught minus x2 into x naught minus x3 into y naught plus x minus x naught into x minus x2 here into x minus x3 divided by x1 minus x naught, x1 minus x2 into x1 minus x3 into y1 plus x minus x naught into x minus x1 into x minus x3 divided by, you have to subtract from the x2 minus x naught, x2 minus x1, x2 minus x3 into y2 plus, so x minus x naught into x minus x1 into x minus x2 divided by, you have to subtract from x3 minus x naught, x3 minus x1, x3 minus x2 into y3. So substituting x0, x1, x2, x3 and corresponding values of y0, y1, y2, y3 in the Lagrange's interpolation formula, we have y of x is equal to x minus x0 is 1 here, x minus 1 into x minus 3 into x minus 6 divided by, you have to subtract from x0 is 0 here, 0 minus 1 into 0 minus 3 into 0 minus 6 into y0 is 18 plus, so x minus 0 into x minus 3 into x minus 6 divided by, you have to subtract from x1 where x1 is 1 minus 0, 1 minus 3 into 1 minus 6 into y1 where y1 is 10 plus x minus 0, x minus 1 into x minus 6, you have to subtract from the x2 value where x2 is 3, that is 3 minus 0 into 3 minus 1 into 3 minus 6 into, so that is y2 where y2 is minus 18 plus x minus 0 into x minus 1 into x minus x minus 0, x minus 1, x minus 3 divided by, to subtract from 6, that is 6 minus 0 into 6 minus 1 into 6 minus 3 into y3 is 90. So this is equal to, after simplification we have 2x cube minus 10x square plus 18. So this is y of x, where y of x is the third degree polynomial. It is an interpolating polynomial. So this polynomial passing through the points 0, 18, 1, 10, 3, minus 18 and 6, 90. To find the slope of the polynomial at x equal to differentiate 1 with respect to x, so that is dy by dx equal to 6x square minus 20x. At x equal to 2, we have dy by dx is equal to 6 into 2 square minus 20 into 2. So this can be written as minus 16. So therefore, the slope of the curve is minus 16 at x equal to minus 2. Move to the so let us consider next problem. Using Lagrange's interpolation formula, express the function 3x square plus x plus 1 by x minus 1 into x minus 2 into x minus 3, the sum of partial fractions. So let us move to the solution. Let take it as f of x numerator function, that is equal to 3x square plus x plus 1, and define the values of x here. Let x naught is equal to 1 here, x1 is equal to 2 here, and x2 is equal to 3 here. So these 3 points are satisfying the function x minus 1 is equal to 0, x minus 2 is equal to 0, and x minus 3 is equal to 0. So these 3 factors are the factors of the denominator of the given function. So now let us establish the f of x values at x is equal to x naught is equal to 1. So y naught or f of x naught is equal to 3 into 1 3 plus 1 plus 1, that is 5. When x1 is equal to 2, so y1 is equal to 3 into 2 square plus 2 plus 1, 2 square 4, 4 into 3 12, plus 2 14 plus 1, that is 15. And x2 is equal to 3, corresponding y3 is here 3 into 3 square plus 3 plus 1, so that is equal to 31. When x naught is 1, x naught is equal to 1, y naught is 5, and x1 is 2, y1 is 15, and x2 is 3, and y3 is 31. So these are the given data points. So let us consider x naught is 1, corresponding y naught is 5, x1 is 2, corresponding y1 is 15, and x2 is equal to 3, and corresponding y2 is equal to 31. So now we have now let us write the Lagrange's interpolation formula. We have Lagrange's interpolation formula, that is y of x minus x naught x1 into x minus x2 divided by, let us subtract from x naught minus x1 into x naught minus x2 into y naught plus x minus x naught into x minus x2 divided by x1 minus x naught into x1 minus x2 into y1 plus x minus x naught into x minus x1 divided by x2 minus x naught into x2 minus x1 into y2. So these are the Lagrange's interpolation formula for the corresponding given data points. Now substituting the values of x and y in the formula, therefore y of x is equal to x minus where x1 is here, 2 into x minus 3 divided by subtract from x0, that is 1 minus 2 into 1 minus 3 into y0 is 5 plus x minus 1 into x minus 3 divided by subtract from 2 minus 1 into 2 minus 3 into corresponding y1 is 15 plus x minus 1 into x minus 2 divided by subtract from 3 here, 3 minus 1 into 3 minus 2 into corresponding y2 is 31. This is equal to 5 by 2 into x minus 2 into x minus 3, but here we have minus 15 because the denominator 2 minus 3 is minus 1, 2 minus 1 is plus 1, that is minus 15 into x minus 1 into x minus 3 plus 31 by 2 into x minus 1 into x minus 2. This implies where y of x is equal to here 3x square plus x plus 1 is equal to 2 is the LCM, 5 times of x minus 2 into x minus 3, that is minus 15 into 2 minus 30 into x minus 1 into x minus 3, here plus 31 into x minus 1 into x minus 2 divided by 2. So throughout equation divided by the factors, divide by x minus 1 into x minus 2 into x minus 3. So this implies 3x square plus x plus 1 divided by x minus 1 into x minus 2 into x minus 3. This implies 5 by 2 is 5 by 2 into x minus 1, x minus 3 get cancelled, so rest is x minus 1 by x minus 1 minus 30 by 2 divided by x minus 1 and x minus 3 get cancelled, so rest is x minus 2 plus 31 by 2 divided by, so here x minus 1 and x minus 2 get cancelled, rest is x minus 3. So the given function 3x square plus x plus 1 by x minus 1 into x minus 2 into x minus 3 can be split into partial fraction by using Lagrange's interpolation formula, that is 5 by 2 by x minus 1 minus 30 by 2 into x minus 2 plus 31 by 2 by x minus 3. So